Welcome back. We're going to continue on in section 10.3 today. Probability unit. This lesson has two targets. First target is I can find theoretical and experimental probability of a given event. And the second target is I can find the odds in favor and against an event occurring. These words are often used interchangeably, but we're going to find out today there's a big difference between probability and odds. I have these targets down at the beginning of your notes so I can check them tomorrow. Okay, so what is theoretical probability? Theoretical probability is really, if you think about it, it's a what-if probability. What if I played a game of cards? What could I get? And what if I rolled the dice? What could I roll? What would be the probability of rolling? That's theoretical probability. We're going to talk about experimental probability. That's a little bit different. But theoretical probability is I haven't played the game, I haven't done the event. Looking at all the possible options and outcomes, what is the probability of a certain outcome happening? So the probability, the way I define it, is favorable outcomes divided by the total outcomes. So what do you want to have happen compared to what will happen? Or what could, what are all the outcomes that could happen? So if we use that definition, we can actually find some probability values. So example 1, standard deck of 52 playing cards has 4 suits with 13 cards in each suit. Find the probability of drawing a spade. Now suits are hearts, clubs, spades, and diamonds. And those are the 4 suits to a standard deck if you play cards. If not, remember you can get out a deck of cards at home. There's a picture in your book of a standard deck of cards laid out. I'm sure if you go online, you can Google search for all cards, pictures, and then I'm sure they'll have them all laid out for you. So there's ways to have it so you can picture it in your head. So the question it's asking is find the probability of drawing a spade. Well, how many spades are there in the deck? There are 13 spades. That's our favorable outcomes. There are 52 total cards. 13 over 52 is 1/4 or 0.25. Here's the probability as a fraction or as a decimal. The thing about probability too, before I can go in much further, is the value of probability. Okay, the probability of an event A is always between what two numbers? It's always between 0 and 1. You can never have a probability of greater than one thing happen. Okay, it's either going to happen or there's a chance it could or could not. If it's going to happen for sure, for instance, what would be the probability of 1? The sun rising every morning. That is a 100% probability that's going to happen every day. So that's a probability of 1. I can't have a probability of a 200% or 300%, or I can't have a probability of greater than 1. Same thing, I can't have a negative probability. If it cannot happen, then the probability is 0. Probability of the sun rising in the west tomorrow is 0. It rises in the east, the sun rises in the east since that's in the west. So things that can't happen are 0. We can't have negative probability. So keep that in mind. If you're doing this correctly, you're going to get a number between 0 and 1. Example 2. Standard deck of 52 playing cards has 4 suits of 13 cards in each suit. Find the probability of not drawing a king. So the probability of not a king, well, if it's not a king, how many kings are there in the deck? There's 4 kings, right? One of each, there's 4 of each kind of card. So there's 4 kings. So our probability is 52 cards minus 4 of them. That's how many outcomes that we want to have happen. And there's 52 total cards. So but not being a king, that is 48 out of 52, which is 12, 13. So again, that's less than 1, greater than 0. Last one, example of getting a red queen. Probability of drawing a red queen. when you want to get a red queen, there are 2 red queens out of 52 cards, or a 1 out of 26 chance of getting a red queen. Okay, so now we're going to incorporate some problems that maybe have some permutation or combination uses. For the first one, what is the probability that students will bat in order of height, increasing and decreasing? Well, we got to go back to the gym class info to figure out where they're coming from here. There are 12 students on your baseball team. Your team, randomly draws names by one by one to determine the batting order. I think I got that. Okay, so we're going to draw names out of a hat. So what is the probability that the students will bat in order of height? So now we're going to assume that everybody is going to bat. So all 12 are going to bat. So if we're going to be increasing or decreasing, so we're talking probability, okay? How many likely outcomes are there, outcomes that we want to have happen? How many outcomes are that we want to have happen? So the probability of in order, okay? And it can be decreasing or increasing. Well, there's only 2 ways we can do it. 1 is in increasing, or 2 is in decreasing. So there are 2 positive outcomes, or outcomes we want to have happen. How many different ways can we order this? Well, that's a permutation. 12 people ordering it 12 ways. You remember in your calculator, you get 12p12, and we're going to get 2 out of 479,001,600, or 1 out of 239,500,500. Not very good. If you put this on your calculator, you get 4.179 e negative 9. What does that really mean? Remember, that's scientific notation. So that means take that decimal point, and we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. We fill the rest of these with zeros. And that's probably as a decimal. Not very likely that the students are going to randomly line up in order, I would say. Let's look at another one. What is the probability that 2 of the 5 females on the team bat first in any order? Well, we want 2 of the 5. It says in any order, so is that a combination or a permutation? That's a combination. We don't care what order. We don't care what order they're in, but we just have to have 2 of the 5 in the top 5 in the batting order. So for females, there are 5 females. We want to choose 2. That's all the ways we can choose 2 females. Compared to, well, there are 12 people on the team, and we could choose any 2 to bat in that spot. If you plug it in the calculator, sorry about that. If you plug that in the calculator, 5C2 is 10, and 12C2 is 66. 10 out of 66, or 5 out of 33, or about 0.15. What is probably that 4 of the 7 male players on the team bat first in any order? Kind of the same idea as this one. If you want to pause it, you kind of bounce off of the last problem here. There's 7 males, we're choosing 4, and we want to bat any 12 in the first 4. Any 4 of the people. How can we pick any 4 of the people for all the spots? Out of all 12 people, I should say, and that's 35 out of 495. Excuse me. We have 7 out of 99. So we can use combinations and permutations to help us count stuff faster, so we can find probabilities of more complicated events. Okay, odds. This is our last section here of this section. That's part of this section. Odds can be written 3 ways: odds in favor and odds against. So 3 ways we can do it. If we think of event A, then A with a bar over it is not A. So odds can be written 3 ways. We always compare favorable to unfavorable. Okay? A to A bar, or A colon A bar, or A and then we have the word to A bar, which is not A. Now we can reverse this. Odds in favor. These are all odds in favor. Okay? And we can reverse that, and then with the A bars on top, it's odds against. So that fraction can be flipped. But that's the 3 ways we can write it. Odds in favor of an event, it simply means favorable outcomes compared to unfavorable. So now we're no longer comparing the total number of outcomes, we're comparing favorable to unfavorable in some way. And how that would be written is like how we wrote it on the top. A to A bar, or favorable to unfavorable. Odds against, then we would flip that fraction. Unfavorable, favorable. Or A bar over A. So they can be written each way. Odds, where do you see odds? A lot of times you'll see it in sports. People will say, what are the odds of the Lions winning the Super Bowl? Right now they're 20 to 1 odds. So 20 favorable to 1, 20 to 1 odds. So that's comparing, there's 20 ways. What that means is really the odds to win the Super Bowl are kind of the unfavorable to favorable. 20 ways to lose to 1 way to win, which doesn't sound very good, but when I was recording this lesson, they were one of the top 10 odds in the league. But basically, that's where you're going to see odds a lot of times. You can sports events, things like that. And odds are different than probability. Probability compares favorable outcomes to total outcomes. Odds compare favorable and unfavorable outcomes. So your probability was between 0 and 1. Odds are going to be any number bigger than 0. Okay? Any number larger than 0 will be odds. So you can get numbers larger than 1. Okay, so let's practice this and then wrap up the lesson for today. We have marbles in a bag, 6 red, 12 yellow, and 9 black marbles. Find the odds in favor of drawing a red. So odds in favor of red. Well, odds in favor of drawing a red. There are 6 reds. How many non-reds? Well, that'd be yellow and black, right? So 12 plus 9, non-red. Okay? 6 out of 21, which reduces to 2 out of 7. Or 2 to 7. So it's 2 to 7 odds that we will pick a red compared to a non-red. We're more likely not to pick a red. Now, probability of that'd be different. Okay, the probability of red, well, that would be 6 compared to all of them. That would be 15, 27, so 6 out of 27. But that's not what we're asking for. So notice the difference. Okay, they're not going to be the same, odds and probability. Find the odds against drawing a black marble. So odds against, that means that the unfavorable are going to be on top against drawing a black. So black, there's 9 of those. Those go to the bottom. But there are 6 plus 12 non-black. Not black. So we reduce. We get 18 ninths. So reduce would be 2 over 1. We have to write that as a ratio. We don't reduce it just to 2. Okay? So that's odds. Odds are comparing favorable and unfavorable events, not comparing favorable outcomes to the whole total amount of outcomes. So I believe we hit both of our targets today. I can find the theoretical and experimental probability of a given event. I can find the odds in favor or against an event occurring. You should feel pretty confident that in those, and we will hone in those skills tomorrow with this on in class. Have a good day.